Hey y'all, welcome back to my channel. So today we're going to kind of step away from the geometry for a little bit just so that we can look at generating equivalent expressions because my students are getting ready to have some assignments over this, so I definitely wanted to show them a little bit, and so I hope that this helps you all as well. But let's get started. So don't forget that this is my Instagram where you can keep up with notifications and just little fun information. Okay, so when we are generating equivalent expressions, it's so important to know those properties of math. And so this not only helps with algebraic expressions, but even when you are in the 3rd, 4th, 5th grade, you're going to be looking at some of these properties with even just numbers. So it is so important and so helpful to know these, and you hear me reference these a lot during my videos. So the first one is a commutative property of addition, and so that is when you rearrange the same numbers in different orders and get the same sum. So just an example, a plus 3, that's 5, like that is the same thing as 3 plus a. So let's just plug in some numbers just to show you. So even if I wrote 2 as a, 2 plus 3 equals 5, well, so does 3 plus 2. So it doesn't matter the order you write it, it's still going to give you the same sum. That also works with multiplication because we do have the commutative property of multiplication. So you can rearrange the same number in different orders and get the same product. So XYZ is the same thing as ZXY because you're multiplying each one of those. So X times Y times Z, remember no sign means multiplication. That's the same thing as Z times X times Y. Even if we plugged in numbers for these, 1 times 2 times 3, that's 6. Well, so is 3 times 1 times 2. 3 times 1 is 3, times 2 is 6. So it doesn't matter how you write it as long as you're using addition in all of it. You're using multiplication in all of it. The order does not matter. You're going to get the same sum. You're going to get the same product. Now remember, that does not work with subtraction and division. In those two operations, order is so important. So now let's look at the associative property of addition. You can add the numbers in any order and get the same sum. So for example, 3 plus a in parentheses plus 5. And don't forget, the order of operations tells us that we always do parentheses first. So if I added these first and then notice that it's all addition, I can add 3 plus 5 first as well if it makes it easier. So let's look at 2. We'll plug in a 2 for a. So 3 plus 2 in parentheses plus 5. Well, 3 plus 2 is 5 plus 5 is 10. Well, then here, 2 plus 3 plus 5. 3 plus 5 is 8, plus 2 is 10. So you're getting the same sum. It's just you're doing 3 plus 2 first in this one, and in this one you're doing 3 plus 5 first. So don't forget that those, and I always tell my students, the associative property, you're looking for those parentheses. But you're going to notice in another property here in a minute that there is also parentheses in those, but the difference is this has all addition signs. So it doesn't matter which 2 you add first, you're still going to get the same product or same sum. Same thing with the associative property of multiplication. You can multiply the numbers in any order and get the same product. So in this case, 3 times b first times c is the same thing as multiplying b times c times 3. So let's just plug in some numbers just to show that one as well. So in parentheses, 3 times 2 times 1 that would be 6 times 1 is 6. So then B times C times 3. 2 times 1 is 2, times 3 is 6. So you're still getting 6 as your product. So don't forget, the associative property has parentheses, and you're adding or multiplying the same thing, different numbers, but still getting the same product or sum. Don't forget that subtraction and division does not work this way. So now, let's look at the identity property of addition. You can add any number, add 0 to any number, and it doesn't change the number. So it does not change the value. So if you want to show how you can add something but still get the same number, just add 0. Because if I plugged in a number, say 3 for A, 3 plus 0 equals 3. The identity property of multiplication, so these are both identity properties. That identity is saying, that's your identity, it's not changing. What can I do to not change that number? So in this case, I added 0, but think about with multiplication. If I multiplied by 0, like 1 times 0, 0 or 1, it would be 0. The answer, the product would be 0. So I want to know what number can I multiply by to still get the same number. In this case, it is 1. So then, say I plug in 3 for x. 1 times 3 still gives me 3. So those two are really the only different ones, in that for addition, you're using 0. For multiplication, you're using 1. So if you see a number times 1, that is the identity property. If you see a number added to 0, that's the identity property of addition. Now, here is a big one, a new one, and a very, very important one that you will see in 6th grade on. The distributive property. When you have a number on the outside of the parentheses with no sign between them. So let's look at the difference here. Well, let me finish this one up, and then we'll look at the difference. When there's no sign in between them, multiply the numbers on the inside first, and then add or subtract. So you're going to multiply all of the numbers on the inside by that outside number. Let's look at the difference here. So we have 3, and then in parentheses, A plus 4. Looking at the associative property of multiplication, the difference here is in the associative property, you're having the same operation throughout. Well, in this one, notice here, I had 3 plus A, but then I also had plus 5. So in this one, I have addition, and then there's no sign between this one. So that automatically makes it multiplication. So that I wanted to show you the difference in those two properties, that yes, this one has parentheses, this one has parentheses, but in the associative property of addition, it's all addition. In the associative property of multiplication, it's all multiplication. So now let's talk about the distributive property. I want to show you how we get 3A plus 3 times 4. And to do that, I'm going to use some algebra tiles. Okay, so I'm just going to first, because remember, order of operations, I'm going to have that inside first. But I can't do anything to A plus 4. I can't add a variable and a whole number. I can't do that. Or a variable and a number, because that's like saying apples and oranges, but you can multiply the oranges by the apples. So like for each apple, you can have an orange, but you cannot add them together and have the same thing. So I'm going to model this. The big long ones, they are your variables. So they are two different colors. You have green and you have red. Red will be negative or subtraction. I like to tell my 6th graders that it is subtraction, because they're not doing operations with negative numbers just yet. They introduced that in 7th grade. So I say negative means subtraction. So green is positive, red is negative. So I have 1A, so one variable, plus 4 ones. So here is our ones tile. We do have a yellow side and a red side. Same thing for the red side, it is negative, but I always tell my 6th graders that is subtraction. So in this case, we're adding, so we're gonna have the yellow side. So I'm gonna have 4 pieces to represent that 4. Now, here's where the distributive property and how, when I do the distributive property, I get this answer. So it's saying, I have this expression, this outside 3 says, I want 3 of those. So 3 times that A plus 4. So that means I'm going to have, to be able to model this, I'm going to have 3 of that same expression. Okay, so now I do have 1A plus 4, 2A plus 4, and 3A plus 4. So if I looked at these individually, I could say, how many A's do I have? Well, I have 3 A's. Well, how many 4s do I have? How many groups of 4 do I have? I have 1, 2, 3. So 3 groups of 4, or 3 times 4. So I could answer that. I could say, hey, I know this is 3 A's because I don't know what A represents just yet. But I do know that I can multiply these 4s because if I counted all these, I would have 12. But to represent and show that distributive property, I'm not going to answer it just yet. But when we start combining like terms in another video, probably the next one, or the next algebra, or numeracy is what I call that class for my students. The next one of that is we will look at combining like terms. So I have 3 A's here, and then plus, because I'm still adding here, it's still positive 4s, but plus 3 groups of 4. So, and I always tell my students, I draw lines to the numbers in the parentheses to make sure that I am multiplying everything, not just one, because that's a common mistake, a common misconception. Not just one, but everything in that parentheses, because you might get to where there's 3 terms in those parentheses. Okay, so, but when I say draw the lines, this is what I mean. So that's like, I'm doing 3 times A, so we saw here, that just gives you 3A because I don't know what A represents yet. And then I'm going to draw another line because I have that 4, so 3 times 4, and I can just say, I'm going to actually do that here. I wrote it out here to show you like how we got that 3 times 4, and it's positive. That sign's not changing. So you might see some subtraction in distributive property, but I tell my 6th graders, just for right now, just bring the sign over, okay? When they get into 7th grade, they can start looking at, oh, that's 3 times negative 4. Oh, that's 3 times positive 4. So, but I say just bring that sign over. 3 times 4 is 12. So this would be an equivalent expression for that 3 in parentheses A plus 4, because this is the distributive property. Okay, so now let's look at some examples. It's going to be kind of a long video, but I wanted to be able to really explain this thoroughly for my students. Okay, so decide which expressions are equivalent by plugging in a value for X. So before we went out of school, before we went to digital learning, we were talking about expressions. So we wrote expressions, and I'll make some videos here in a little bit or a few days from now that reviews that writing expression and evaluating expressions. But I wanted to get this out because you're going to see assignments for this week or next week. No, sorry, this week. This is going to be coming out on Monday. But so remember that X, I don't know, it doesn't tell me what that X is, but remember we looked at X equals 1, X equals 2. X can equal anything. So I'm going to make this easy and say, okay, I'm going to make that X represent 1. Okay? So that means for each of these expressions here, I'm going to plug in, because they all have X, I'm going to plug in 1 for X, and I'm going to solve those expressions so that, or evaluate those expressions so that I can see what their solution is. To see at the end, we're going to see the ones that have the same solutions will be equivalent. Okay, and don't forget that word equivalent, I always tell my students, what does the first 4 letters sound like? Or the first 3, I guess. It just means equal to. So which ones would be equal to each other? So let's start plugging in. So 5, don't forget, no sign means multiplication. So 5 times 1 plus 65. Well, 5 times 1 is 5 plus 65 is 70. Okay, so now let's look at 5 times 1 plus 1. That would be, remember parentheses first. 1 plus 1 is 2, but there's no sign in between here, so that's 5 times 2, which is 10. Okay, so here is 1 plus 5 times 1. No sign means multiplication. So order of operations, I do multiplication first. 5 times 1 is 5, plus 1 is 6. So now let's start doing all these. We're still plugging in that 1. 5 times, because right here we have 70, 10, and 6. I don't have any same solutions. I don't have equal solutions just yet. So 5 times 1 plus 1. Well, 5 times 1 is 5, plus 1 is 6. Ooh, look here. I have the same answer here. So that means that 1 plus 5x is equal to 5x plus 1. Okay, so now 5 times 1 plus 5. Well, 5 times 1 is 5, plus 5 is 10. So that means I have 2 equivalent answers here. I have 10 and 10. So 5x plus 5 is equivalent to 5 times x plus 1. Okay, so now I have 5 in parentheses, 13 plus, plugging in 1 for x. Order of operations, I'm doing 13 plus 1 first, which is 14. No sign here, that's multiplication. So 5 times 14, that's 70. So that is the same solution as we got for the first one. So that means that 5 in parentheses 13 plus x is equivalent to 5x plus 65. And if you look here, thinking about those properties, we can consider this one term, this another term. I'm adding, well, 1 plus 5x is the same thing as 5x plus 1. So that is the commutative property. We're just switching the orders of addition because our sign is addition. Even though we do have a multiplication here, I don't really know what that is for, without plugging in a variable. So I could say this is one thing, this is one thing. Let's just model that, just for fun. So 5x, so 5 variables, plus 1, 5x plus 1, I can just switch this around. I didn't change anything. I still have the same thing. I still have 1 and still have 5 x's. So I just wanted to show that for you. Now here, I went from parentheses with a number on the outside with no sign to this, which is the distributive property. They distribute that 5 to that x, so 5 times x is 5x. 5 times 1 is 5. Same thing here. Look at example 2. So, use and identify a property to write an expression that is equivalent to these expressions. Okay, looking at A, all we have is x plus 3. So let's just model this for funsies. And remember, people at home, if the modeling helps you, you can draw these long things and put like a little plus sign, little square. So, but I have x plus 3 ones. Is there any other way to write this? You can switch this variable to over here, and so instead of saying x plus 3, I now have 3 plus x. That's the only other way that I can break that one down or rewrite it. So, what property is that? That is the commutative property. And what operation are we using? Of addition. It is so important to write that, of addition, of multiplication, because you'll see we have 2 commutative properties, we have 2 associative properties, but you need to specify which one you're using. In this case, I am using addition. So now, looking here, I have a set of parentheses that's saying A times B first times C. Well, I have all of the same operation. It's all multiplication. If I wanted to, I could multiply B times C first. So I'm still using the same variables. I'm just saying, instead of multiplying A times B first, I'm multiplying B times C first. And that, since there's parentheses and all the same sign, that's the associative property. And what operation? Of multiplication. Okay, so now looking here. This one is kind of going to be a little bit more difficult. But let's just first model this. So I have 3y's and I have, they're all the same variable, but then I have 4y's. How can I break this down or rewrite it so that I could get the same answer? So, looking at this, I could say I have 3 of the same variable and 4 of the same, plus 4 of the same variable. So I could say y times 3 plus 4. I look at what is the same. In this case, the y is the same. What's different? This one has 3, this one has 4. So here, and even if I wanted to answer this or solve this, 3 plus 4, or 3y plus 4y, if I added these together, gives me 1, 2, 3, 4, 5, 6, 7y. I added that 3 plus 4 here because parentheses first. 3 plus 4 is 7 times y is that 7y. Okay, now this one, we have just whole numbers. 6 times 7. Well, there's no other way to really, well, let's think about it. 6 times 7 is 42. Is there another way that we can use these same numbers to get the same product? Well, 7 times 6 is the same product because 7 times 6 is 42. So I just switched my order here, which means that is the commutative property of, what operation did I use? Multiplication. Last example for today for writing equivalent expressions. So, we're going to use the properties of operations to determine if the expressions are equivalent. Now, if you notice in all three of these examples, we have the distributive property. Okay, now this one is a great one I want to show you and I want to model with you. Okay, 3 of x subtract 2. So I'm going to model x. Now I'm using subtraction, so I'm going to use that red side. If you want to model it, you can use crayons to color and draw your little squares, or you can just put little subtraction signs. So I need 3 of these expressions. Okay, so I have 3 of these expressions. And that's what this tells me. Even if I distributed it, I would say 3 times x. So here I have how many x's? I have 3 x's. Well, then I have 3 times 2. Do I not have 3 groups of 2 here? If I counted all of them, I have 1, 2, 3, 4, 5, 6. So, and they're all red. So that's subtraction. 3 times 2 is 6. So does this equal this? Yes. So I would say yes, they are equivalent. Okay, so now let's look at this one. I have 2 plus x. So I could write that x plus 2 using the commutative property. But I'm comparing it to this one. So I need to, this right here is a distributive property. So I need to distribute that 1/2, or that 0.5, so 5/10. We can also think of it as 1/2. I'm going to distribute it, which when I distribute, I'm multiplying because there's no sign in between the parentheses and number and decimal. So 1/2 of 4 is 2, but then I also have to distribute that 0.5 or that 5/10 to that x. Well, 5/10 of x, and it's positive, is just 5/10 x. So this is a great example as to, or of, when my students like to just multiply one or the first term, and not, if I just multiplied the first term, it would be 2 plus x, which is equivalent, but I still have to distribute that 5/10 to that x as well. So it gives me 5/10 x. So no, they're not equivalent. So now here is another great example. I'm even going to model this one for you. So I have 3x and then 5, we're going to subtract 5. 3, 4, 5. So now this is one of my groups. Okay, that's one of my groups. I need 2 of those groups because I'm multiplying 2 times this expression. So I'm going to have another group of 3 x's subtracting 5. Okay, so now if I combine these, how many x's do I have total? 1, 2, 3, 4, 5, 6. So 2 times 3x is 6x. So remember, you can multiply. You can multiply that 2 times that 3x. Then 2, so I'm just going to bring that sign down because these are all subtraction or negatives in 7th grade. But 2 times 5, so how many of these did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm subtracting 10. Does this look, is it equivalent to this expression? Is it the same? Well, the 6x is equivalent, the subtraction, but then I have 8 and 10. So no, they're not equivalent. Okay, so I hope that this video helps you. I hope that this will help my students. Don't forget, if you have questions, you can always email me or message me. But I hope that this helped you. Don't forget to give this video a thumbs up. Don't forget to hit that red subscribe button so that you can see all of my videos that I'm making to help students on math throughout this crazy time of the coronavirus. But I hope y'all are staying safe and healthy, and we'll see you next time. Bye, y'all.